most people are familiar with the Gartner hype cycle, which I think is quite informative in this sense. It's this idea that when something new comes along, a lot of people get very excited and think it's going to change everything. And at some point, when it doesn't sort of materialize into this world-changing event, people become disappointed and disillusioned, and they start to think it was all hype and it's all nonsense and it's not good for anything. And then eventually it sort of levels out and people develop a realistic understanding of the value of the tech. And I think with blockchain, we're at the point where we have just sort of passed through that sort of peak of the hype cycle, and people are now asking, is this really a thing? Is this a solution that's in search of a problem, or is this going to be doing anything useful in the future? So in other words, we tend to overestimate the short-term impact of technology and underestimate its long-term value. So you mentioned AI, that's the classic example, right? Many products and services that we use today leverage AI and sometimes machine learning aren't referred to as AI products. So mapping and route finding tools are used in the travel industry. Some of the more advanced grammar and writing tools use AI technology, recommendation and summarization, auto transcription. They're all products that don't feel the need to boast about their underlying tech because they solve the actual problem. So they're selling a solution to the problem, not the technology stack that lies underneath it. And I think that's a really important way to tell the difference. So I heard somebody say just the other week that if somebody says something about blockchain, the first thing to do is take away the word blockchain from the description and add the word database. And if it's still exciting, then it's worth paying attention to. So just remove the concept of the technology to it in your own head to assess its value. So at the end of the day, blockchain it's a database technology with a specific set of characteristics, as Alexis explained. From a practical perspective, what that actually means is that once it's set up, it does not require an organization to act as the gatekeeper. There's no need for somebody to act as a police force to ensure the integrity of the database because it's self-correcting. So what that does mean, the downside of that, if you like, is that changing the structure of that database is not as simple as it might be for other types of databases, like a SQL database or document database or a knowledge graph. So blockchain acts as this sort of ledger, if you like, allowing any authorized person to read the data and then to add another event to the end of the chain, which is why it was used for its obvious first use, which was transactions in cryptocurrencies, and why now it's being used in things like rights management, which is what Jane's going to talk about. So is there something in scholarly publishing or scholarly communications that would really lend itself to that type of database? That's the question we need to ask. So I personally see possibilities around things like version management of outputs, papers and datasets, protecting the integrity of datasets, especially in areas that are targets for bad actors. And I'm thinking about things like environmental science. It might be useful for protecting the integrity of academic CVs, or for fighting predatory publishers, and for other types of high-value, high-risk information resources. And I think that's the place where we kind of have to look for the applications of it. So what I would say, I think, is that blockchain already has uses in other industries. So it's not, a technology in search of a problem. It will have successful uses in our own technology, but it's not going to solve everything. There are other types of databases which are better suited to other types of problems. The question is, what are the specific problems that this will be a good solution for?